Hello, Precalculus student. This video is for chapter 3.4, part 2, about graph of polynomial functions. And we were analyzing x-intercepts from the point of view of just a formula. If you have the formula, if you have the polynomial formula factored, each individual factor corresponds to a x-intercept. And then if you look at the graph, if you look at the graph, the x-intercept actually corresponds to a 0. So you can kind of, figure out that, okay, so when you see a x-intercept, it must be a x minus h of something. And to distinguish between the power, we have these three phenomena that we see earlier. If the graph crossed the x-intercept most likely linear, then the power is 1. And we call it the multiplicity is 1 or single zero or single root. The graph touched the x-axis and bounce off, then it is an even multiplicity. The lowest number is p equal to 2. And if the graph crossed the x-intercept at a 0, but not in a linear way, but like kind of a curved way, then it's a 0 with odd multiplicity. The lowest number is p equal to 3. Okay, so we can look at a graph that we have. That's what we talked about in the last video. Look at this example. We have a graph but no formula. So can we write the formula? Before we do that, we can say, okay, so what are the zeros? So there's 1 zeros. That is, the first one is equal to -3, right? 0 is h. So I won't say h. We would say the 0 is -3. This one. And it's bounced off, so it's an even multiplicity. So we say p equal to 2 or even, right? And then the second one is -1, right? Equal to -1. The 0 is a -1. The power is across it and rather linear, so we say multiplicity 1. The third one is this one, is x equal to 4, or the 0 is equal to 4. So the multiplicity is, it's kind of curved, but it crosses it. So we would say 3 or odd, right? So, and then we can also kind of know that the function itself would look like, have something that contain x plus 3, x plus 1, and x minus 4. For x minus 4, because it's odd, so we say 3 to the power 3, and x plus 3, because the 0 is -3, because it's x minus h, right? So if you have -3, it becomes plus 3. So this is a power 2. So of course we have some other coefficient, like we had an a or something, but this is kind of the way that by looking at this graph, you can actually kind of write the function out like that, matching all the zeros, basically reversing the 0. You can say x is equal to -3, so you add 3 on both sides, become x plus 3, like that. The reverse is, well, if I have the factored form, can I write the 0 and multiplicity and then figure out how it behaves in the graph? We can do it the other way, right? So in this particular case, this one is all factor. So x equal to 4 is a 0, and then the multiplicity is 2. And the other one is, so this one is x plus 1 equal to 0. I should say like this. So x is equal to -1 is a 0, x equal to -1. The multiplicity is 3. So this x equal to 4, earlier we say, okay, we know any -1, and we know a 4. At 4, multiplicity is 2, so it bounces off. So it's either like this way or this way. We don't know which way, okay? And then for -1, because the multiplicity is 3, so it's either this way or that way, right? So we don't know which way, but we know that it's one of these two for the 2 function. So we'll use other hints to graph the whole thing, but we get the picture of the graph a little bit more and a little bit more and a little bit more. When we have a non-factored form, so we would just need to factor it. So now this one is a little more tricky. Oh, I forgot an x here. Otherwise, it's very hard to factor. So this is 9x cubed minus 12x squared plus 4x. So of course the common factor is x. You factor it out, become a quadratic. So far we can only factor quadratic. Now this is a ax squared minus bx plus c. We have to use diamond, but AC diamond. 4 times 9 is 36. You have to do 4 times 9, not just 4, okay? Because 9 is not 1. Then negative 12. Think of two numbers. When you multiply them, they are 36. When you add them, they are negative 12. So it will be 6 and negative 6. Well, actually, both negative 6 because when you multiply them, it's positive. When you add them, it's negative 12. So x, we have to do grouping. So 6 is not the answer. So x squared minus xx minus another 6x plus 4. And so it will become x. Factor this 2, so it will be 3x. 3x minus 2 minus 2. 3x minus 2. And you can see that the common factor is x outside. Inside is 3x minus 2. 3x minus 2, they are actually the same. So they are not factor 1. They're identical. So we write it as x 3x minus 2 square. So the multiplicity, so we have 2 zeros. I'll run out of space. 0 is equal to 0 because x equals 0. The multiplicity is equal to 1. 0 equal to 2 over 3. Why? Because let's do it this here over here. 3x minus 2 equal to 0. So 3x equal to 2. X is equal to 2 over 3, right? You just solve it. The multiplicity is 2. So you can visualize it as at 2 over 3, you have something that bounces off top or bottom. And at x equal to 0, it passes through it. Okay, so how do we complete the whole graph? So we talk about this again. Even multiplicity means the graph touched or tangent to the x-axis. Odd multiplicity means it intersects the x-axis. Okay, so to graph the whole thing, we would need to find the multiplicity, how it intersect the x-axis. Is it touching it, or is just passing through it? Is it passing through it linear or non-linear? After you do that, then you determine the end behavior, because the end behavior determines how the graph starts, and then it would lead to finishing it. And also determine symmetry if it is even or odd function, and also find y-intercept for a accurate number on the graph. So let's sketch this graph. So this is already factored. So you should always factor them because you start off with zeros and multiplicity. That's your first things. In order to do that, you have to graph them. So I have x equal to 3. X minus 3 equal to 0. Multiplicity is 2. So it touches it, right? And x plus 5 equal to 0. So x is equal to negative 5. Multiplicity is 1. And then what is our leading term? In order to do this, we also need to know the leading term. These are a few things because I want to know end behavior. So step 1, remember, step 2 is leading term. Leading term, that's just 1. It's negative 2 times x squared times x. Negative 2 x squared and 1x. So it's negative 2x cubed. So for a negative x cubed, we know that the graph is like this, right? It's reflection of like x cubed. So we would start to graph, putting our zeros there, negative 5, and then 1. So for what? Negative 5? Oh, and then not 1 is 3. 1 is the multiplicity. So this one we know it is pass through, and this is this is a pass through, and this is a bounce off because the multiplicity is 2. So because the graph goes to the positive infinity on this side, so we kind of get in the graph here. It is passing through, so we pass through it, and then we have to go back to 3, right? Because 3, we have to go back to the x-intercept, and it bounces off. And so you can see that this is our graph. Next one. So remember the steps. The step is factor. It is already factor. So find zeros. 0 is x is equal to -1, multiplicity is equal to 1. X is equal to -3, multiplicity is also 1, all pass through. And x is equal to 4, multiplicity is 3. So this is pass through but nonlinear pass through. Leading term, because leading term determine M behavior. And for M behavior, I'm going to just draw a picture. Okay, is 8 times x times x times x cubed. So it is 8x to the 5th. So we know that the graph and behavior would be kind of like just like the x cubed things. It falls on the right, it falls on the left, rise on the right. So I'm going to graph all the zeros. So the first is -3, or on this side, we graph from left to right, and then -1, and then 4. So because it fall to the left, so I go from left over, and these are all passing through. This is strict pass through. At 1, you have to come down, also strict pass through. But at 4, it is a kind of like a x to the cube pass through. Okay. The last one, g of x equal to 4x cubed, x plus 2, x minus 2 squared. So remember this also. If you find 0, so x is equal to 0 is 1. So zeros, I will write it down here. X equal to 0, p is equal to 3, so it passed through but non-linear way. X equal to -2, -2 is p is equal to 1. But when x is equal to 2, p is 2. So this is the one that it will touches. So this would be either like this or this, and these are strict, and this would be either this or that. Okay, so let's graph them. Oh, and then also end behavior. So leading term, what's the leading term? -4x cubed times x squared. -4x cubed. The coefficient is very important. Times x squared. So this is x to the 6, right? -4x to the 6. So that means down, down. So in a way, it's down, down. So I'm going to graph all the zeros. Or I know I have a 2, -2, I have a 0 and a 2. So start from here because it drops on the left. So start from here to go to -2. So this one is -2. At -2 is pass through straight. And then I need to go down to 0. At 0, it is also straight but curving. And then at 6 equal to 2 is a bounce off. So I don't go through it, I bounce off like that. Okay, it's not very good. I don't know. I think it should be like that. Yeah, it should be like that. So there's some kind of curve around here. Okay, so you get the idea on how to graph it. So that's how using zeros. Now, then you might say, Ms. Chan, when you say you pass through it and then you drop down, how far away? How like is it right in the middle? It's not. So now these are turning points. Turning point cannot be found by algebraic method. You would have to use calculus method to find the turning point, and they are also called local maximum. When we talk about this in chapter 1. So I am going to stop here, and then in the next video we're going to talk about how to write the formula of a polynomial function the other way around. In this section we look at the formula and sketch it. Next we're going to find the formula.